Okay, the next separation method that we are going to look at is when we separate two liquids that mix well. Okay, recall if your liquids do not mix well, we use a separating funnel to separate them. But if they mix well, right, we use distillation. So there are two types of distillation, the fractional, simple distillation or the fractional distillation over here. Okay, so distillation essentially the setup is we have a round bottom flask, right? The two liquids that mix well, we put it inside, and then there will be a thermometer connected. Okay, this thermometer must be placed at the bulb of the condenser over here. Okay, and then there will be constant heating, and then this part is where I collect the individual distillate. Okay, so usually I will put boiling trips inside here. This one is to minimize bubbles formed during boiling to smooth the boiling process. Okay, the temperature over here, the thermometer bulb must be placed at the opening. Okay, so the bulb cannot be too low, because if it's too low, you are measuring a lot of direct heat from the burner. It cannot be too high. Okay, why is it so? It's because this bulb is measuring the temperature of the vapor that is leaving the distillating flask, and then that is entering the condenser. Okay, so what's going to happen here if, for example, I have two liquids? Okay, if I have water and then salt water. Okay, salt water, essentially salt is like a impurity. So your boiling point of salt water may be 102 degrees Celsius. Your boiling point of H2O, I'm sure you all know this is 100 degrees Celsius. Okay, so what's going to happen when you start heating it? Once it reaches 100 degrees Celsius, your thermometer will show 100. When your thermometer show 100, you should know that all the water is turning into water vapor over here. When they turn into water vapor, they enters the condenser, right? And then once it enters the condenser, what is happening in the condenser? There's cold water entering at the bottom over here, and then my hot water is constantly being pumped out. Okay, so cold water is usually found at the bottom near where we are collecting, because this is to allow for effective condensation. Okay, my hot water will constantly be pumped out at the top. Another thing to note, right, is my condenser must be slanted. Okay, it must be slanted to allow the gas to touch the walls, the cold walls easily, so that condensation can take place effectively. Okay, if it is horizontal, it is limited. The condensing is limited. Okay, we must know this, the cold water coming in must be at the bottom, and then this is to allow for effective condensation. Okay, your hot water will be constantly pumped out from the top. Okay, when we are trying to collect the distillate, right, we always use a conical flask, right? Conical flask, why is it so? It's because they have a narrower mouth. This will prevent spillage, maximum distillate collection. Okay, and then we use a beaker with ice, right, if the distillate is volatile. So for example, alcohol is a very common volatile solvent. Okay, volatile means it turns into gas very easily. So alcohol turns into gas very easily. I use ice, right, to ensure that the distillate does not turn back into gas. Okay, so what's going to happen, right? All my 100 degrees, my water will collect as distillate. After all your water is collected as distillate, your temperature over here will start to rise again. So when it goes up to 101, 102 degrees Celsius, once it hit 102 degrees Celsius, which is the boiling point of your salt water, all the salt water that's left behind here will start to boil. When it boils, it will enter the condenser again, right? I know it's 102 degrees because your thermometer will show 102 degrees. It will touch the condenser, change a conical flask, use a new conical flask to collect the salt water in this case. Okay, the difference between your simple distillation and your fractional distillation will be this whole column called the fractional column. Okay, so your fractional column or the fractionating column, right, inside there are glass beads. Okay, these glass beads, what do? They provide a surface area for a higher boiling point vapor to condense and fall back as liquid. Okay, so what happens? Sometimes your boiling point can get very close, and then because it is constant heating over here, maybe because of evaporation, even though here shows 100 degrees Celsius, some of my 102, maybe because of evaporation, will actually become gas. But when they become gas, they don't enter the condenser because it's not their boiling point yet. So they touch all these glass beads, right? And then they will condense back over here. So my salt water with 102 degrees will condense back over here, right? And then only the 100 degrees can enter the condenser to be collected here. Okay, so fractionating column, what do they have? They have glass bead inside. This glass beads as a surface area to allow the liquid to condense back and to fall back if it haven't reached their boiling point. Okay, let's look at the bottom. Okay, so the setup we have already discussed. This is when your solution boils and then it vaporizes and enters the condenser, right? When it enters the condenser, we know that it is the pure vapor because of the boiling point shown on the thermometer, right? And then in the condenser, it will cool and condense back into the distillate to be collected. Okay. When do we use fractional distillation? Okay, when this fractional distillation, we usually use it when there are 3 or more miscible liquid. And then their boiling points are very close, less than 25 degrees Celsius. So some common examples, we have separating crude oil, we have separating air, multiple components of air, there's more than 3 components. We have nitrogen, oxygen, carbon dioxide, water vapor, etc. Okay. And then to separate ethanol. Ethanol, this is your volatile liquid, so you use fractional distillation.